Hi everyone, welcome to eBizChat, where it is all about business. I'm Rick Zanotti, and I'm joined by my good friend, Dr. Susan Nash. Susan, how are you?
Good, and we're trying a different format today, so I'm excited about it.
Yeah, we're going to go quicker, faster, and to the point. I don't know, can we do that? I think we can. And joining us in a moment or two will be Harold Muliati. He's our video producer, but he's also helping to co-host. Here we go. This show is sponsored by Relate Corporation. Visit us at www.RELATECasts.net. Thanks. Well, Susan, we've got a couple of them. There's Harold, by the way.
Here
and we've got a couple of companies we're going to talk about today. What's the first one we want to talk about?
Well, I think that, okay, first of all, our new format. So we're picking two companies that have new technologies and are kind of looking to the future and doing things that are changing sort of energy sources, diversifying energy sources, and also improving sort of infrastructure, things that we've been hearing about lately everywhere. So there's the first one is Sensytec, and they have smart concrete. And I just think it's so fascinating. There's a little video we can watch in a second that kind of shows what they do. But the whole idea, I don't know how many I guess everybody's familiar with what happened in Florida and Surfside, the condominium collapse. And they're now finding that like concrete failure is a bigger thing than they ever expected.
Right. Now, what did you think smart concrete, before we get into the video, what did you think it was when you heard about it?
When I first heard it, I thought smart concrete meant it had some way of controlling it or monitoring it so that there's sensors in it. When I think smart, I think sensors.
Okay.
What did you think?
I thought it had some sort of self-healing properties, where maybe nanoparticles or something else that could sort of heal itself, maybe from cracks, from some heat stress or something else. Because there are compounds that are starting to do things like that. And I go, oh, maybe that's what it does. I also thought sensors as in, maybe conducting electricity somehow or something, but I wasn't quite sure on that. Harold, what did you think it was?
Well, I guess when I hear the word smart, I do usually think that there's some sort of connection to a centralized system or something like that. It kind of goes with, for example, we've talked about things like smart pipe and other technologies like that before, where it's almost like a way of having preventative medicine for architecture and infrastructure, where the earlier that you can find out stuff, then the more ability you have to fix something affordably.
And the only other idea I had is maybe it's some edible concrete, but I thought that would be not good for digestion. Right, so we play the video and find out what's behind door number one.
Yes, absolutely.
The mission of Sensytec is to give users real-time data on what's happening with their cement. We have a technology, Smart Cement, to monitor the structural integrity and health of concrete structures.
Can be used in oil wells, concrete pipelines. Highways are all made out of concrete.
If there was any kind of change in the integrity of a bridge per se, any kind of stresses, corrosion, essentially any kind of damages, you would know it and be able to then go and fix it. We want to help make sure that there aren't so many catastrophic failures.
That's pretty amazing. When you think, we're in California, and when we have earthquakes, they specifically damage concrete and brick buildings the most. And structures like bridges, they get hit really hard. So imagine what this could do with all those kind of sensors. They could catch, maybe even ahead of time, where some of the issues could be, how to report on some of those issues, and as well as maybe figure out after an earthquake. Then I'm thinking earthquake only because that's a real common one here. whether there is damage, because sometimes there may not be visible damage, but it could be there. It could be internal. Yeah, and this is fascinating.
Well, I know. And the thing, okay, there are two things. First of all, they say the way they make it is that they have nanoparticle fibers that they mix into the concrete that actually then if you put the electrode in, it changes. And so you've got a monitor. And so those are like sensors that I guess are not, I don't know how they would, I mean, in a pipeline, you've got pigs and you've got these little coupons that change, and they tell you something, there's corrosion. So, I mean, this obviously is going to change, like set up a signal or a circuit so that you can tell if something's happening, especially if it's close to the rebar, I'm thinking.
So these are like little carbon nanotubes?
Yes, I think so.
Well, it's interesting because I think we talked about this in a previous show, that with carbon nanotubes, they're planning on making paint that you can put on rooftops or on walls that would have carbon nanotubes that would conduct electricity. And just like solar panels would be very similar, but it would actually generate from the paint on walls and roofs the electricity. Pretty fascinating. Again, so that's one of the technologies out there. This may be a similar approach.
Yeah, from how this sounds, it sounds like it's a very similar thing because it sounds as if you've got these fibers going through, probably if there's a crack and it causes something to shift in that cement, then you probably have some sort of change in electric potential that lets the sensor know. And that is interesting that it's fibers all throughout. It's almost like the whole block of cement is a big sensor, and I assume I'm not too sure, but I assume that it would have some ability to let you know where in the cement that the so that is pretty interesting.
Now, you were mentioning what happened with the Miami condo building, how it collapsed, and a lot of it had to do with rebar, with water, with cement cracking and breaking and deteriorating. So this would be the kind of thing that, if it worked well, it could be caught way ahead of time.
I think so. In fact, they've actually they've identified at least 2 other buildings that they declared unsafe.
Oh, really?
After they started looking more closely at their columns and the pillars.
Interesting.
And usually, and when you think about the piers and also the support columns, and also just the floors, because you see those cracks. But like I've noticed that, like on the Surfside thing, they said that a lot of the worst was covered by a planter.
Oh,
so, as you and Harold are saying, you don't even know that it's happening unless you have some kind of sensor.
And that was all by the pool area. And then, so that kind of, they had figured that out. Yeah, they may have been able to avoid it later on. Hard to say. Because they said also construction methods have changed a bit since that time. So that could have been part of the problem. And one of the comments they made is that the way the building was built, especially in the pool area, they allowed water to just basically stay, what's the word for it? Not stale.
Oh, was that in the underground garage? And the tide came in where they had this like king tides.
And they allowed the water to stagnate and dry by evaporation rather than get rid of it. So they were planning on making changes to that. That was one of the recommendations made by the people who reviewed it, but a little too late, not soon enough.
Oh, so terrible.
Yeah.
And I think
those were not cheap. That wasn't a cheap building.
this.
And that wasn't a cheap building either. The average price was like $1 or $2 million for the places there. So, yeah, it's misfortunate accidents based on just little things. And those little things turn into pretty big ones. Well, Sensytec, we hope you do well. It's a really fascinating venture, and it sounds really brilliant. Do you know where they're located?
They're in Houston.
Houston. Go Texas. Keep it up. That's some pretty cool stuff.
And then the next one is a little different. I'm intrigued by this one because essentially it's a way to use geopressure to create make turbines run and generate electricity. But it's kind of like kind of a geyser concept or a gusher that you pump water down an existing well, and then you just, when it's cheap and electricity is cheap, and then, or you heat up the water and pump it down, and then after time, you just let it back up, and it gushes up. You hope it doesn't blow out, but it gushes up and starts turbines running, and that generates electricity.
Interesting.
So in that case, and the company, by the way, is called Quidnet Energy. But what I was going to say is, in that case, yeah, it's in a way, it's almost like a hybrid of energy generation and energy storage. I guess you need to use energy to put it down there, but it is a way of storing a large amount of energy and then being able to take it back out later, I assume.
Now, are they putting this into dormant wells, or are these active wells?
It wouldn't work to put them in active wells, because you kind of have to like just let it sit there for a while. So it's like a battery.
Okay.
Well, or potential, because essentially you've got and here are a couple of things I wonder about. Okay, let's say that you want the water to be hot, you want it to be under pressure, so you're pushing it down there, and then you're capping the well, and you just have to really monitor the pressure. But there are a lot of things that come to mind, and this is just the geology in me, or geologist in me. If you've got put things under pressure, you have the potential to create induced seismicity, and I'd like to know how they've investigated that, and then also some of these places that they're pumping stuff into, it's not all that friendly down there. I mean, like, you're familiar with the Ventura field, right? Like, what do you see signs of on all those producing wells? Is going, warning, H2S problem.
Yeah.
Right.
Is the Ventura? Where is the Ventura field?
In Ventura, California.
That's what I thought. Yeah, it's the one I'm thinking of. But that's not far from us,
That's what yeah.
We're about 20. We're not even 20 miles away. I think 15 miles. So yeah.
Yeah. You can drive up the Ventura, and it's been a long time, but when I went to Ojai and those areas, we did a little investigation. But I just noticed, I was going, ooh, these are all H2S laden wells, and so
And for those who don't know, what is H2S?
Oh, it's hydrogen sulfide, and it will kill you.
Yeah, it's toxic. Yep.
Mm-hmm.
Yeah.
But I think it's a great idea. I mean, it's just a great idea, a way to reuse old wells, use technology, reuse it, and then put some turbines in there, and basically have a different kind of hydroelectric power.
Mm-hmm.
Yeah, and like I said, it also the problem of storing a huge amount of energy for potentially a pretty long amount of time is something that's there haven't been a lot of really great solutions to. For example, like I know that like one of the main technologies used for that now is like vanadium redox batteries, but again, the thing is they take up a lot of space. They're not efficient as far as space goes, and while something like this, like what Quidnet's doing, would take up a lot of space, it's, the space is already taken up by the well, so that kind of, you don't have to necessarily build the really big energy storage facility. A lot of it will be just using the well itself. So that's part of what makes it interesting to me.
Yeah, and they've got a video, and it starts about a 1 minute mark. It gets into kind of like what they're talking about. I don't know if we can show a little bit of that. They also have a diagram.
Let me see. They have it on there.
Well, I put it in the... watch how it works. And then you go to about the 1 minute mark.
We're focused on... Energy storage has been around for almost 100 years via pumped hydropower. Today, we generally put energy storage into three main buckets. First, thermal energy, think heating and cooling. Second, chemical energy, mostly batteries. Third, mechanical or kinetic energy. That's storage for movement or pressure, including pumped hydro. The Department of Energy has been a leader of energy storage R&D since the late 70s. Today, several national labs focus on energy storage for transportation, buildings, healthcare, and grid-scale solutions. Recently, the DOE announced a storage launch pad alongside an advanced energy storage initiative to supercharge and better target grid-scale storage research and development at national labs. The launch pad is expected to make its home at Pacific Northwest National Lab. There are exciting things happening in Congress, too. Bills like the Better Energy Storage Technologies Act, or the BEST Act, are underway. Quidnet Energy is one of the energy storage companies we are closely watching. We think their technology is revolutionary. They've received funding from ARPA-E at the Department of Energy through the DAYS program, as well as significant private investment from the likes of the Prime Coalition and Bill Gates' Breakthrough Energy Ventures. Quidnet uses a technology called geomechanical pumped storage, a technique with similarities to traditional pumped hydropower. Just to recap, traditional pumped hydropower uses upper and lower reservoirs to create an elevation change, mimicking traditional hydropower. The water is pumped uphill by excess electricity to store the energy and allowed to run downhill through turbines to generate electricity again when we need it. For context, pumped hydro is almost all of grid-scale energy storage today. The issue with pumped hydro is that it requires elevation changes such as mountains and a water source nearby like riverways. Not only are there physical restrictions for locations, the construction costs can be quite high, anywhere from hundreds of millions to billions of dollars, and they can take years to license and build. This geomechanical pump storage, or GPS technique that Quidnet uses, applies the concepts of pumped hydro by repurposing drilling and well construction techniques to store energy in the form of pressurized water in underground rock. So how does this store energy? To charge, water is pumped down a well into a pressurized water pool. During discharge, the well top valve is open and the pressure in the well is released directly into the water turbine, which generates electricity. GPS does not require specific physical location, such as mountainous terrain, and is less than half the cost of traditional pumped hydro. Not only can these projects use a mature and accessible supply chain for parts, they can be small and located almost anywhere, and they don't impact existing rivers and lakes. Interestingly, GPS can also be used to repurpose fossil fuel assets as well, from using old coal plant ponds to end-of-life oil and gas fields. Quidnet's GPS is a promising technology as we look towards a future with a high demand for long-duration energy storage. Thanks for listening.
Yeah, so it's interesting. We'll see where that goes. Where are they located?
They seem to be all over. They have offices in Houston. Their president is in San Francisco, but he's going to be coming to Houston next week for a workshop and the North American Prospect Expo. So it's very interesting to see how people are really trying to find ways to create more energy for us. I mean, energy is important.
Well, yeah. And like I said, there are, when it comes to large-scale energy storage, there's, in a lot of cases, not a really great solution. And this is a way that, as he explains in the video, it's like a kind of like a better version of the traditional pumped hydro, because you don't have to build as much stuff, so it's less expensive. And just, I guess, kind of inherently, when storing a lot of energy, that does come with a certain amount of danger. So it will be interesting to see how they solve some of the problems that you mentioned, like, potential for seismicity from the pressure and that sort of thing.
Well, at least it doesn't silt up like a dam. I mean, I don't know how many dams are in trouble, but I remember hearing about one in California that was in trouble.
Oh, there was one in the north. I remember about I'm trying to remember which one it was. There was one up in Northern California. I can't remember if it was what river was that? I'm not recalling right now. I think Howard's looking it up.
Well, one of the things, too, they aren't talking about, but it always occurs to me, is that if you've got that much energy sitting there,
is it the Oroville Dam?
Can't you use some of it?
Yeah, I think so.
What was it?
The Oroville Dam. Sorry.
Oh, interesting. Yeah. Oroville, yes. I was thinking, actually I was thinking was it in Siskiyou County or something like that, but anyway.
Yep.
So the issue is water, obviously, like in these, you don't have to have a lot of reservoir water. You don't have to be in a mountain. You can be close to a city. And you can also potentially use the water, that energy to purify some of the water that's like brackish or unusable now.
Right.
Sounds good. Anything in the news? Anything else we want to cover today? I know one thing. Cargo containers are still very expensive. They keep going up. And again, that's hurting supply chain everywhere. So don't know if that's a political thing or really a shortage thing. Just not sure. But they said it's causing a lot of delays for manufacturing parts and products, as well as just getting orders out to people. So it's just sort of interesting.
I guess the problem is that the ships they don't want to have an empty cargo.
No.
And so they just sit there and then there's, I guess, a shortage of them anyway.
Mm-hmm.
But I wonder what used to be on them shipping out across.
Yeah, because I'm not sure what.
Here.
Yeah, I'm not sure what would cause a damage or a shortage now versus before. Don't know. That's sort of interesting. I don't know if it's a fabricated or prefabricated problem or if it really is a problem. Hard to say nowadays with international politics, laws, and shipping. There's a lot of factors that go into all of that. So not sure. Not sure what's going on there, but there is an issue with getting products here, at least at the moment.
Whenever there's anything like that, I always start suspecting oligopoly.
Right.
Maybe it's not, but
it could be. It very well could be. Anything else you guys want to talk about? I guess not.
Well, I don't know if you can hear pounding. I've got a new roof. They're putting a new roof on. The hailstorm, speaking of supply chain and challenges, hailstorm happened April 28th, and now we're just finally getting roofs.
Oh, gosh,
Okay.
really?
I had figured that
Wow.
was your drum circle that you had to get to right after this, Susan.
Well, anyway, I guess that's it for today, folks. We will see you next week on eBizChat. Thanks, everyone. Bye-bye.
Bye, everyone.
Bye.